Welcome class 9. Today we are going to learn about comparison of speed of sound with speed of light. So the first difference, we can say, the comparison is the light waves can travel in vacuum but the sound waves cannot. Number 2, the speed of light is 3 into 10 to the power 8 meters per second in air, and the speed of sound is only 330 meters per second in air. The speed of light is 3 into 10 to the power 8 meters per second, means 3 into 10 to the power 5 kilometers per second. That means 3 lakhs kilometers per second in air. Whereas the sound only can travel 330 meters per second in air. So we can understand that the speed of light is very, very high compared to the speed of the sound. Okay. So the speed of light is much greater than the speed of sound. So number 3, the speed of light waves decreases when it travels through vacuum, gas, liquid, and it cannot pass through solids. Whereas the speed of sound decreases when it travels through solid, liquid, gas, and in vacuum it does not propagate at all. See, this means that the speed of light waves is maximum when it is traveling through vacuum. Then when it travels through gas, its speed slightly decreases. Then when it travels through liquid, again its speed will decrease, and when it you know uh, is incident at the solids, it cannot pass through the solid, so its speed becomes 0. Whereas the speed of sound decreases when it travels through solid. See, the maximum speed of sound is when it travels through solid, okay, and decreases when it travels through liquid, and in gas its speed again decreases, and in vacuum it does not propagate at all. So it's just the opposite. In case of light, it's the vacuum with the maximum speed, and in case of sound, the vacuum is the thing. The vacuum is the place where it cannot travel only. Okay, it cannot propagate at all. So these are three, and this is the third difference. And the fourth one is the light waves are transverse electromagnetic waves, while the sound waves are longitudinal mechanical waves. So the light is an electromagnetic wave that we have already learned, and the sound wave is a mechanical wave, and these are the four most important differences. All right. So if the light has the greater velocity, much greater velocity compared to the speed of sound, okay, then what are the consequences? So what are the consequences that we can see physically? Number one is, in thunder, light is seen much earlier than the sound of thunder is heard. So the flash of light that we see first, okay, then later on, after few seconds, we can hear the sound of thunder, isn't it? So even though both the sound and light are produced simultaneously when the thunder strikes, okay. So this is number one. Number two, when the starter in an athletic event fires a gun, a spectator who is sitting at a distance hears the sound of fire a little later, while the smoke is instantaneously seen. Okay, you may have noticed this kind of events happening. Number three, while watching cricket, the spectators hear the sound of stroke a little later than the batsman is seen actually making it. So most of you have uh, you know noticed this, may have noticed this, that when the batsman hits the ball, the the picture is seen first. Okay, the sound of hitting the ball is heard little later. So this is because the light travels much faster than the sound. Okay, so all these three consequences are because the speed of light is much greater than the speed of sound. Now, the factors which are not affecting the speed of sound in a gas. Okay, in the previous class we have learned about factors those affects the speed of sound in a gas. So here these are the factors which will not affect the speed of sound in a gas. Number one, the speed of sound in a gas does not depend on the pressure. Okay, so the pressure has no, it does not affect the speed of the sound. Number two, the speed of sound does not depend on the amplitude of the sound wave. And number three, the speed of sound does not depend on the wavelength or frequency of sound wave. So we here just see that wavelength or frequency. That means wavelength and frequency must be connected, isn't it? So the speed of sound does not depend on the amplitude. That it also does not depend on the wavelength or the frequency of the sound wave, and also it does not depend on the pressure on the medium of where the sound passes through. All right, so if the frequency and the wavelength has some relation, then let's find out the relationship between the wavelength, wave velocity and the frequency. In schools, we have learned that distance is equal to speed into time. Similarly, we have wavelength is equal to wave velocity into time period, where wavelength is similar to distance, wave velocity is similar to speed, and time period is similar to time. So in that way we can write that lambda is equal to v into t, where lambda is the wavelength, v is the wave velocity, and t is the time period. Okay, so if lambda is equal to v into t, and also we know that time period is the inverse of frequency, so t is equal to 1 by f. Now if lambda equals vt, then we can replace this t by 1 by f in this equation. So lambda becomes equal to v into 1 by f. Now this f in the denominator, if it is cross multiplied with lambda, then we'll get f into lambda is equal to v. So we get v is equal to f lambda. This means that v is the wave velocity, which is equal to frequency into wavelength. So wave velocity is equal to frequency into wavelength is the relationship between a wavelength, wave velocity and frequency of the sound wave. Okay, so this much for today. Thank you.